This week we move to Module 12. We will talk about very important relationship in the object-oriented programming. We will talk about polymorphism. What is polymorphism relationship? The polymorphism relationship actually came from inheritance relationship. Last week we talked about the inheritance relationship. We have the parent class, or in C++ we call base class. So then we have child class inheritance from the base class. So this inheritance relationship, for example, the account class is a base class. So the saving account, checking account, they all inherited from the account class. Same as shape class is the base class. Circle, rectangle, they all inheritance from the shape class. So when we have this inheritance relationship, because saving account inherited from the account class, can I say saving account is one kind of account? Yes. So that's we say in the inheritance relationship, we have is a relationship. So this is a relationship actually is a child class object is a base class object. So for example, saving account is one kind of account. So circle object is one kind of shape object. So that's we have the is a relationship. So that's because the is a relationship. So that's make our account class actually have many forms. We can say account is account, but account also can show like a saving account, because saving account, checking account, they all are an account object. Because this inheritance relationship, we make the sometimes we have some object they have many forms. Because I can say saving account is an saving account object, but I also can say a saving account object is an account object, because the is relationship came from inheritance relationship, and the is a relationship bring us the polymorphism relationship. So that we have the polymorphism relationship. So fundamentally, polymorphism relationship is came from the inheritance relationship. But you need to be careful. The child class object is always a base class object, but not reverse. A base class object is not a child class object. Just say, for example, a shape object is not a circle object, because we are not sure. The shape object maybe is triangle object, maybe is rectangle object. So that's why we cannot always say a base class object is a derived class object. So in order to show you the polymorphism relationship, so that's why moving forward, we want you to using the example at the end we have from the last week. Did you remember in the last week, we have our commission employee? Because the base plus commission employee both have commission and the base salary. So we make the base plus commission employee inherited from the commission employee class. So please using this example, the last version we have from module 11. So then we will demonstrate to you what is the polymorphism relationship. Like earlier we say, commission employee inherited from the base plus commission employee. On the other hand, base plus commission employee is an commission employee object. How we will demonstrate that? So actually here we want to do is, we will create two pointers. The first pointer is commission employee pointer. So this commission employee pointer is a parent class pointer. So that's it here. Actually, this one is the base class pointer. So after I create a base class pointer, can I use this pointer to refer to a base class object? Of course, they are the same type, right? Good. So continue. Then we create a base plus commission employee pointer. So this one is derived class pointer. So on the other hand, can I using this pointer to refer to a derived class object, the base plus commission employee object? We can, right? Good. So that's why here we mean if I have two objects I create. So these two objects actually we both using the new, or we're using a dynamic memory. So we created parent class object. I'm using the parent class pointer to refer to that. So then I have a child class object. I'm using the child class pointer to refer to that. Totally no problem, right? Right. So then since I have a pointer, so can I using the parent class pointer to invoke the print function? So when you do that, actually this one mean is, so I using the parent class, sorry, this one is parent class object to invoke the print function. Yeah, that's okay, right? So actually this print function from commission employee. So the same thing, remember in the child class, we also have a print function, right? So if I using the child class object to invoke this print function, for sure, this print function actually is from the child class. So the same thing, then can I using the parent class pointer to invoke the print? Right, as long as we're using the arrow. Of course, we can do that. So the same thing here, this print function actually after we invoke, this print function is from the base class. Because this pointer point to the base class. So the same thing, if I using the base derived class pointer, so to invoke the print function, so this print function also from the derived class. You all agree, right? Okay, so now the next one is, how about I change a little bit? Since earlier we say the child class object is one kind of parent class object, right? So now can I using the parent class pointer to refer to the child class object? Yes, we can. That's the polymorphism because the child class is one kind of parent class object. So that's why we're using the parent class pointer to refer to the child class object. So now the next question is, so after through this pointer, parent class pointer, I can invoke the print function, right? Good. So this print function actually both implement and declare in the parent class and the child class. So when we're using the parent class pointer to invoke the print function, and this parent class pointer actually refer to the child class object. So which print function they will display? In this example, actually this print function will invoke from the commission employee class. So that's the base class. Okay, we will show you why and we will give you the result. So that's why here I want you to make sure you will download all the source file. So this one actually is under our example 1, 2, 3 from module 12 folder. So you have the parent class header file and the CPP file. and the child class CPP file and the header file, and the driver program. So now the driver program I just want to show you here. So in the driver program, right, we create a parent class object and the parent class pointer, child class object and the child class pointer. So here they just didn't point to the correct object yet. So now here, right, so then we're using the parent class object and the child class object to print. So just like we say, they will print to their associated class because that's the object. So after you have the parent class object to call the print function, of course, they will invoke the print function from the base class, same as the child class print. So now we have the parent class pointer to refer to the parent class object. So then this print still the same because you point to this parent class object, right? So of course we think that is correct. The print function actually will from the base class. So the same thing from the child class pointer to refer to the child class object, the print function will invoke from the child class. But how about the last one? The last one now I'm using the parent class pointer refer to the child class object. So this one we don't have compiling error. The reason is because for inheritance, child class object is one kind of parent class object. So you can assign to that. But when they invoke print, what happened? So that's why you can see the output. This output from the object invoke, they are fine because they are print from the object itself. So when you have your pointer to refer to the object, they also still print correctly. You see, like the child class, right? Not only we have the commission rate, we have the gross sales, we also have base salary. So the second one, when we're using the child class pointer to invoke the child class print, the base salary also display. But here actually is the last one. When we call the print function, we're using the parent class pointer to refer to the child class object. Then actually that print function is came from where? It came from parent class. So that's why you don't have the base salary display. Why? Because there's no relationship. Remember here, when we are in the parent class object, they have print function. The reason here they will print from the parents class, that's because this pointer is parent pointer. And here, when we're using the child class object to invoke the print function, because this pointer is a child class pointer, so that's why the print function will invoke from the print. But when you're using the parent class pointer to refer to a child class object, they have no idea which object they really refer to, because from the parent class pointer, they only have the information for the print function by itself. They have no relationship between the print function from the child class. So that's why they will have the print function invoked from the parent class. Here we want to emphasize the result actually show you is that's mean when you have each print function, print member function, they are in different object. But one thing is we care the print function how they invoke is according to the type of handler. So that's because the pointer type is the parent class type. So of course the print function will print from the parent class. So that's for example 1. So example 2, actually they are still using the same header file and source file. But now we show you here is because the parent class is not a child class object. So that's why here if you try to using the child class pointer to refer to a parent class object, you will have compiling error in example